Hey class, in today's lesson we're going to talk about dividing polynomials. Alright, so I know we never really do bell works on our videos, but I think this one's a really good one to help us in practicing dividing using long division. We probably haven't needed to divide by hand in a long time, and so sometimes we forget that process. So let's practice. We're going to divide 5,269 by 15. So in order to do that, remember what that process looks like. You will take the outside number, which is 15, and we'll see if it fits into 5. It obviously doesn't fit into 5, but it will fit into 52, right? So how many times? So in other words, we're going to take 52 and divide it by 15. So 52 divided by 15 gives us a whole number of 3, right? And then at that process, then I take 3 and I multiply by 15, right? So 3 times 15 is what gives us 45. Now, at that point, remember we changed the sign of 45 to make it negative 45, and we subtract. So we're going to subtract 52 minus 45, and we get 7. And then our next step is to bring down our next number, which is 6. And then we start all over again. So now it's 15 and 76. So 76 divided by 15 is going to give us a whole number of 5, right? At that point, I multiply 5 times 15. 5 times 15 is going to give us 75, right? We change the sign to make that subtraction. We get 1 and bring down 9. Start the process over one last time. 19 divided by 15 is 1. It only goes in there once. 1 times 15 is 15. Change the sign and we get 4. And then I told you at this point I want you to write the remainder as a fraction. So our answer is 351 plus, because the remainder is 4, plus 4/15. Because it ends up being whatever your remainder is on top over the divisor. So what we're dividing by, that's a S. Okay? And so that's the exact same process that we're going to go through with long division. So here we go. Our objective is to divide polynomials using long division. All right, so in our first example, we need to go ahead and set that up. So x plus 5 goes on the outside. And then I have 4x squared plus 23x minus 16. All right, so just like in the last problem, we need to be sure that, well, not in the last problem, we didn't do this in the last problem, but we need to be sure that there are no gaps in powers. So we need to check to be sure if it starts with squared or second power, then it goes second power, first power, no power. So that's exactly what we have here. We have a second power, a first power, and a no power. So instead of seeing how many times x plus 5 goes into 4x squared, we just check with x and 4x squared. So what that looks like is it becomes 4x squared divided by x. Now I won't write this out every time, but I'm just showing you for a visual the first time. If I divide it by x, I'm left with 4x. So this becomes 4x up here, and then I multiply, right? So this becomes 4x squared, and 4x times 5 is 20x. Remember, the next step was to change the signs. And then 23x minus 20x becomes 3x, and I drop down my next number and start over. Okay, so now I'm checking with x and 3x. So 3x divided by x is 3. And then I multiply that 3 to the x plus 5. So 3 times x is 3x. 3 times 5 is 15. All right, we change our signs, and we're left with negative 31. That is our remainder. So our quotient is 4x plus 3, and our remainder becomes negative 31 over the divisor, which was x plus 5. And we are done. Okay, let's try that again on the next one. All right, so let's rewrite this. So this becomes x minus 7 and 3x squared minus 29x plus 56. All right, so we check to be sure that there are no gaps. There are no gaps here, right? Because there's a second power, a first power, and a no power. So we start dividing. We're going to check with x and 3x squared. If I do 3x squared divided by x, that's going to be 3x. So then 3x times x gives us 3x squared. and 3x times negative 7 is negative 21x. We will then change the signs, and this becomes negative 8x. Drop down the positive 56, and we start over. Now we're checking x and negative 8x. That becomes negative 8 on top. If we multiply, that becomes negative 8x and positive 56. We're going to change the signs here, and this works out perfectly because there is no remainder. So our answer is just going to be 3x minus 8 with no remainder. All right, in example 2, the first one, at this point, we're just trying to check to see if it is a factor. So what that means is if there is a if our binomial is a factor, then that means that there will be no remainder. So on the first one, we're going to check to see if it is a remainder. And then the second one, we're going to check to see if it is a factor. And then if it is a factor, then we're going to write that function x to the 5th minus 32 as a product of those two factors. So let me just show you what I mean. So on the first one, we have x squared plus 1. And then we have 3x to the 4th minus 4x cubed plus 12x squared plus 5. Now here's the deal. On this particular problem, we have gaps in two locations. We have a gap on this first section because it goes from second power to no power. There should have been a first power in here, so we're going to have to rewrite it with a first power here. And then there's once again a gap here between 12x squared and 5. There should be x to the first power somewhere in there. So if I rewrite this, I'm just going to write it below it so that you can see it. We're going to have x squared plus 0x plus 1. You just need a placeholder. 3x to the 4th minus 4x cubed plus 12x squared plus 0x plus 5. Okay, now I'm going to tell you now I'm going to run out of space. So what I really need to do is rewrite this a little higher. So I'm going to erase this and just write the second one at the top line. So here I go. All right, so like I said, with the gaps filled in, I'm going to have x squared plus 0x plus 1. And then here I'm going to have 3x to the 4th minus 4x cubed plus 12x squared plus 0x plus 5. All right, so we start. 3x forward and x squared. If I do 3x to the 4th, divided by x squared is going to give me 3x squared. If I multiply, that gives me 3x to the 4th. This is going to give me 0x cubed. That's why I want to use that 0 because it gives me a place filler, and I'm not going to forget and accidentally put a product under a location that it doesn't belong. And then 3x squared times 1 is going to give me 3x squared. All right, change our sign. So this is negative, negative, negative. The 0 doesn't matter about it being negative, but oh well. So this cancels. I'm left with negative 4x cubed and 9x squared, and I still need to bring down my 0x. All right, so now I'm checking x squared and negative 4x cubed. So that becomes negative 4x. If I multiply negative 4x by x squared, I'm going to get negative 4x cubed. If I multiply negative 4x by 0x, that is also 0x, and negative 4x by 1, that becomes negative 4x. Okay, change the signs. And that becomes 9x squared and 4x. And then I bring down the 5. One last time. Okay, I'm checking x squared and, x squared and 9x squared. So 9x squared divided by x squared is going to give me 9. 9 times x squared is 9x squared. 9 times 0x is 0x. And 9 times 1 is 9. If I change the signs, that was really plus, so that'd be negative now. That would give me 4x minus 4. So here's the deal. Since I have a remainder of 4x minus 4 and not 0, then that means that x squared plus 1 is not a factor of that polynomial. Okay, so we are done with number 1. Now let's go through the process on number 2. Let me erase this. All right, and by the way, on number 1, it's not a factor. All right, so on the second one, we're going to test that same theory. Now, before I even write it out, I want to point out that there are clearly some gaps here. So we're going to need to rewrite p of x as all those gaps in there. So here we go. We're going to check. So we have x minus 2. We're just trying to check and see if it is a factor, and if it is, we're going to write it as a product. So here we go. This becomes x to the 5th plus 0x to the 4th plus 0x cubed plus 0x squared plus 0x minus 32. Okay, we're going to check x and x to the 5th. That becomes x to the 4th. If I multiply, that becomes x to the 5th minus 2x to the 4th. I need to then change my signs, and this becomes 2x to the 4th, bring down 0x cubed. Okay, now I check x and 2x to the 4th. That becomes plus 2x cubed. If I multiply, that gives me 2x to the 4th and negative 4x cubed. If I change the signs there, that gives me 4x cubed, and now I need to bring down 0x squared. All right, now I'm checking x and 4x cubed. That's going to give me plus 4x squared. If I multiply, that's going to give me 4x cubed and negative 8x squared. If I change the signs, that's going to give me 8x squared, and I need to bring down 0x. Okay, so now I'm checking x and 8x squared. That's going to give me plus 8x, and I need to bring it up over here. So 8x squared plus 0x. 8x squared times, 8x times x gives you 8x squared. 8x times negative 2 is going to give you negative 16x. And I only moved this because I ran out of space. Change the signs. This is going to give me 16x, and don't forget I need to bring down this negative 32. So last I am checking x and 16x, so that's going to be plus 16. 16 times x is going to give me 16x. 16 times negative 2 is negative 32. Change the signs. The remainder equals 0. So as a product, p of x equaling negative 32 is really a product of, we can rewrite as p of x equals what the divisor was, which is x minus 2, times our quotient, which is x to the 4th plus 2x cubed plus 4x squared plus 8x plus 16. And we are done. So lastly, on try 2, we're going to do that exactly like we did on the last problem. Once again, realizing that there are gaps in the divisor and in what we're dividing. Okay, so here we go. If I rewrite it, that really is x to the 4th plus 0x cubed plus 0x squared plus 0x minus 1. Being divided by x to the 5th plus 5x to the 4th plus 0x cubed plus 0x squared minus x minus 5. All right, so here we go. X to the 4th and x to the 5th, that's just going to give you x. So x times x to the 4th is x to the 5th. Plus 0x to the 4th plus 0x cubed plus 0x squared minus x. We're then going to change the sign of all that. The zeros don't matter, but that last x does. This becomes 5x to the 4th plus 0x cubed plus 0x squared. There are no x's, so I'm going to say plus 0 and still bring down the negative 5. All right, so now we're checking x to the 4th and 5x to the 4th, so that becomes plus 5. 5 times x to the fourth is 5x to the fourth. 5 times 0x cubed is still 0x cubed, plus still 0x squared. 5 times 0x is still 0x. I should still say x. And then 5 times -1 is -5. Once I change my signs here, everything cancels. So p of x is the product of our divisor, which was x to the fourth minus 1. I'm just going to write the original, right, from up there. And then our quotient, which is x plus 5. All right, guys, that is it. If you have any questions, remember, come see me for tutoring.